Equality. It's going to be x plus 2y is greater than 0. Okay? So what do you have to graph first? So what was that thing you have to graph first? You have to graph... Well, what are you graphing? Are you graphing a pony? What are you graphing? A line. What did we call that line? We called it the boundary line. So that boundary line is x plus 2y equals 0. So this is in what form? Standard form. And I like you to find what if you're going to graph things that are in standard form? X-intercept and y. Just find the intercepts. So when x is 0, what's y? Really? When x is 0? 0. So what is the only intercept of this thing? 0 is not an intercept. An intercept is a point.
Isn't it 2?
If I ask you for a point and you say 7, that's not correct because you need 2 numbers to describe a point.
0.
Correct. And what is that called? So this goes through the origin. So we would need another point. So if we need another point, how do we get another point? There's lots of different ways to get a second point. What's another way to get another point?
Isn't 2y, so 2 is the y?
If x is 0, you have 2y equals 0. 2 times what equals 0?
0.
So it's 0, 0. So when y is 0, what's x? X equals 0. It goes through the origin. So if you have 1 point, how would we go about finding the second point? There are many second points. Harrison, what's one way? You could use the slope. Absolutely, you could use the slope. There is no other intercept because this is the intercept, right? So you could. So 2y is equal to negative x, so y is equal to negative 1/2 x. So what does that mean, negative 1/2?
That means it goes down 1/2.
Down 1 over 2, so something like this. And what do you do once you have those 2 points? Connect them. And there's a draw tool here with under draw. You can draw with line. Oh, look at that.
It has to be dashed.
Okay, I'm going to make it, yeah. So next I'm going to ask, is it dashed or solid? And it's dashed because it's strictly greater than. There's no equals. So make sure it's dashed. That's important. You won't get full credit unless it is. So you can go through and do this. There you go. And now you have to test. And you're testing a point. What point did we like to test the last class? Can we test 0, 0? Why not? It goes through it, right. So how about 1, 1? Is 1 plus 2 greater than 0? Yes, it is. So do we shade above or below? 1, 1 is right there and it works. So do we shade above or below? Above. There it is. The point 1, 1 worked. So you shade the side that 1, 1 is on. 1, 1 is on the above the upper side. Yes, Nikki. Compound inequality for me. What does that mean, Alex?
It means that y is less than 5 and y is greater than negative 5.
Correct. So there's 2 of these things, right? So what are we graphing? We need to graph y is less than 5 and y is greater than. To graph those, you need the boundary lines. Y equals 5. What kind of line is y equals 5? What kind of line is y equals 5? Horizontal, exactly. It is horizontal. And what about y equals negative 5? Horizontal. Are these going to be dotted or solid lines? Dotted. So one of them is going to be up here at 5. So that's y equals 5 right there. And then this one's going to be negative 5. And where do we shade? Do we shade between them, outside them? Well, you're going to shade between because this one goes down like this. And then the other one goes up. So where do they overlap? They overlap in between. Right here. There it is. There it is.
That's it.
That's it. First thing you need to do, what was that first word? Draw. We're going to graph the what? Boundary line. And what is the boundary function? X plus 4y equals negative 3. What form is that in?
Standard.
So what should we find?
The
Just say the intercepts. If x is 0, can someone tell me what y is? If x is 0, what's y? Negative 3 over 4, yep. And if y is 0, what's x? Negative 3. What do you do with those 2 points? You plot them and you connect them. Yeah, you draw one specific line. You draw the one that passes through both of them. So where's 0, negative 3? Right about here. Do I really care how... Oh, sorry. It's negative 3, 0. What am I doing? Right over here. Do I really care if the scale is perfect? No. It needs to be good, but it doesn't need to be perfect. This is one thing I see that you should not do. Here's what you should not do. Please don't. It's a waste of time. Stop it. Stop it. Yes.
What did negative 3/4 be like?
We haven't done negative 3/4 yet. I have this. I'm sorry. This. And then 0. And then 0 negative 3/4. If that's where negative 3 is, there it is, right there. So.
Why would it be less than 1?
I'm just putting it there and labeling it. It's okay. I was doing it in relation to that negative 3, which is beyond. I'm not using the grid in the back. So I now connect those 2 points. I draw your line. What are you going to end up with? Something like this?
Yeah.
Is it going to be solid or dotted?
Solid.
What point do I like to test?
0, 0.
Yeah. Is 0 plus 0 greater than negative 3? It is. So we shade. Oh, I want to get a different color. You guys have infinite amounts of color. Use them. Hey, there it is. Okay, put everything away except a pencil, please. And so, start off with these 2 words right here. What do you think the most 2 words there are in that objective? What do you think the most 2 important words are? What's one of them, Mar?
Independent.
Independent, yeah. What's the other one? Dependent, right. Okay. How many people have seen these words in math before?
Psychology, too.
Psychology, yeah.
Physics.
Generally speaking, which of the variables that we look at are we going to call the independent variable?
X.
X, yeah. What about the dependent? Y. The x values are the things we're going to put into a function and a relation, and the y values is are the things that are going to come out.
You dyslexic?
What? What's wrong?
Oh, and I thought you were going like uppercase N.
Oh, no. You know what I didn't know until I looked at it? Someone actually had to explain this to me. You know what the logo, so this is our logo for Williston, right?
Yeah.
But there's something that's not actually the logo. What's the thing? What have I not done?
Isn't that like a wild
There's a weird N in there.
It's not, yeah, look, this is deleted, right?
Yeah.
What do you see? There's an N.
Oh.
It's Williston Northampton School. I totally didn't know that until recently. Okay, so we have input and output. You have your independent variable, kids, and your dependent variable. So next, here we go. Let's move on. Here's the thing. We've looked at lots and lots of functions. Here's something that we've looked at that is a function. We've called them functions. They are functions. Y equals 2x plus 9. That is a function. That is a function. Y equals x squared. That's another function. Functions live inside a bigger set, though. That bigger set is relations. Something can be a relation, but not a function. What that means is all functions are relations, but not all relations are functions. So functions live inside the set. So you have this set, we'll call it functions, and then we have relations. What is a relation? Well, we're going to zoom way out here to the biggest set we can get to. A relation is any set of ordered pairs. So Nick, give me a point. Give me a point. Any point. Make it up.
Negative 3, 1.
Negative 3, 1. Excellent. Aubrey, give me another point.
The 4 and 6.
Do you know what humans are really bad at doing? And this, I'm just bringing this up because it's just a fact of humans. We're really bad at making stuff up. It's really funny when we're really bad at randomizing things and just picking things out, because when we make decisions, we base it on something. It's really hard for us to spontaneously think of something. Like, think of nothing. You can't, right? It hurts. It hurts. My mind is folding. What did you say? 4 what?
6.
4, 6. Okay, I'm changing color arbitrarily here. Give me another point, Zoya. Any point. 7, 3? Okay. This right here, that's a relation. It's any set of ordered pairs. There's a really important word in there. What do you think the really important word is? Ordered. It's not any set of pairs, it's any set of ordered pairs, meaning the first coordinate is x and the second coordinate is y. There is an order. In our case, it's going to be x, then y. If we don't have ordered pairs, we don't have a relation. Here's a relation. I'm going to draw some axes, and then I'm going to take my marker here, if I can get at it. Whee! Is that a relation? Yep. Could I take lots of points on here? Yeah. And the relation is that they are on this squiggle. I'll ask you a question you might know the answer to. Is this a function? This is not a function, but it is a relation. The relationship is that all those points are on that path, but it's not a function. Now, this is the definition they use, and they use a couple others, and I'm not a big fan of how the book verbally describes functions. I think it uses too many words. We can read it out loud. A function is a relation in which, for each value of the first component of the ordered pair, there is exactly one value of the second component. This is what I want you to remember. The first of a few things. If you see that shape, if an x value goes to two different y values, it is not a function. So you have that little like mouth eating a frowny face. It means not a function. What I mean is an x value can't have two. It's the same thing as this, just said a little differently. What this means is every input has one output. Every input has one output. So for every value you plug into the function machine, or whatever you want to call it, you can only get one thing out. If you get more than one thing out, it's not a function. It's a relation. It's only a relation because every function is a relation. So here's a relation. It's a set of points. What do you think? Is this a function? Yeah. 1 goes to 2, negative 2 goes to 4. These are all different x values. So, great. What about, so this was a function. Nice. Function. What about this right here? A few more points. What do you think? Is this a function?
No.
This is more than one that has that.
Well, which one are you focusing on, Nick? Which 2 points?
The last two.
The last 2. That's 1 going to 2, and it's also 2 going to 2. Is that the shape I drew you?
Yeah.
No, it's not.
Well, kind of.
It's not, though. It's the opposite of the shape I gave you. I said x value can't go to 2 y values. Can more than one x value go to the same y value? Yes. For example,
So there's a relation.
this would be a... No. This is okay. That is the opposite shape. Look at the shape I drew you up here, Nick. If an x value goes to more than one y value, it is not a function. Look down here. Is that what I have? No. What do I have? I have 1 going to 2 and 2 going to 2. Is that okay? Yes.
Why
It's-
is it, I don't understand why it's okay.
Look, okay, I'm not, okay.
You can't
The
have the same
rule-
x's, you're saying?
What?
X values, you can't have the same x values.
Let me go back to here, okay. Does everybody understand this picture right here?
Yes.
I need you to understand the rules right now, not why the rules are the way they are. I just need you to understand this rule. X can't go to more than one y value. So let's look at this list right here. Just answer this question for me. Are there any x values here that go to more than one y value? Answer that question. Are there any x values there that point to more than one y value? No. Therefore, this is a function.
Is it the same thing as like, you know, the functions that go?
Sure, we can
But
turn
it's
this.
basically the same thing. Then I
The
guess
same thing
it
as
can't
well.
be-
These are the same. Yeah, so ready? Yeah, look.
Yeah, like that.
Negative, these are x and y coordinates. This is the exact same thing. I'm just writing it differently. Absolutely. See this? These are the same thing. This is the table. This is the table of values right there. Same thing. What do you see? 1 goes to 2 and 2 goes to 2. Is that okay? I'm telling you, yes, it is. It's okay for more than one x value to go to the same y value. You can't have the opposite. One x value can't go to 2 y values. Are there any x values here that go to more than one y value? 2 is the same y value, right? Is this okay? Yes. Yes, it is. Yes, it is. This is the shape you need to remember right here. If x goes to more than one y value, it is not a function. So what about this one right here? Is this a function?
No.
No, because negative 2 goes to 1 and negative 2 goes to... This means it's not a function because negative 2 goes to more than one y value. It's not a function. It's not a function. You have the same x value, but different y values. Can you write functions in different ways? Absolutely. What do you think of this? Well, this is a function because 1 goes to its own thing, negative 2 goes to its own thing, and 3 goes to negative 1. Can someone tell me why this is not a function right there? Why is h not a function? Alex, sorry.
Negative 2 goes to 1 and 0.
Yeah, negative 2 goes to 1 and 0, so it's not a function. It's not a function. If we graph those 2 points, negative 2, 1 and negative 2, 0, what would it look like if we graphed those 2 points? Anybody want to take a guess? What does it look like if you graph those 2 points? They don't overlap directly, but what does it look like? They're on the same what line? Yeah, vertical line. There's negative 2, 1, and negative 2, 0 is right there. What are they on? The same vertical line. So we're going to get to something in vertical line land. Oh, here's a picture of a function. Let me get this out of here. It's the same thing. Here's the table of values. Here's the graph right here. This is definitely a relation. The question is this a function?
Yes.
It is?
No. Yes.
That one is.
Stand by it. You're right, Aubrey. You're right. This is a function. This is a function. Is there anything that has an x value of negative 2 that also has 4? No, it's clear. It's clear here. If there was a second one, you would see it above or below this point. You would see it above or below or above. Based on just these 3 points, are these 3 points a function?
Mm-hmm.
Yes. How many points are on a line?
A lot.
In infinite, a lot. Every time I say, I'll just say infinite. There's a lot. This is a relation. Is it a function? Are there any x values that have more than one y value?
No. Oh, yeah.
Really? Pick an x value. How many y values do you get? Pick any x value. I'll pick this one. Oh, I got that y value right here. Pick this x value. Oh, it's that y value right there. Are there any x values that have more than one y value? No. So what is this? A function. So let's say I changed it just a little bit. Let's say I changed it and I said, okay, you have this line and I'm adding in this one point right there. If I add in that one point, is it still a function? Because look, what's right below it? Another point that has the same what? The same x value. Can 2 points have the same x value, have different y values?
Yeah.
On a function.
To be a function, yeah.
To be a function, no. They can't. You can't have this. This is not a function because you see these 2 points right there? That point right there could be what? Negative 2, negative 4? And what does that one look like? Negative 2, 2? You have the same x value but different what?
Oh, so yeah, that'd be a relation.
Well, they're always a relation. That would not be not a function. All relations are function, but not all.
Functions.
Exactly. Exactly. Sometimes you see this picture, which I like putting in mainly because I can't draw the function machine myself. Sometimes you see this as the visualization of a function. A function is just something that does something to inputs. You plug in 4, you multiply it by 2 as the function machine, and what do you get out? 8. Because the function is y equals 2x. You see the function right there? You just, I just like putting this in. I'm not too good at drawing the gears, so I just like putting it in. Again, here's that phrase that we started with. In a function, there is exactly one value of the dependent variable, the second one, for each value of the independent. Excellent. I've seen these 2 words before. A few of you maybe?
SSATs.
SSATs, nice. Anybody want to define using a sentence what the domain of a function is? Or can you tell me anything? What's the domain of a function? Summer?
I have both of them in my hand.
But do you have an idea?
No.
Anybody have an idea? So you've seen the words before, but you have no idea what the domain of a function is? Mar, what is this?
Independent or x value.
It's the one? Or
I
it's...
said it independent is the x value.
That's correct. So how is that related to domain? How many input values could a function have?
As many as
Exactly. So the domain is all of them.
Yeah.
So this is the set of all input values. What's the range then? The set of all what? Output values. Exactly. So if I gave you this relation right here, oh, it gives a definition there. But if I gave you this relation right here, can someone just tell me really quickly what is the domain of that relation? What are the input values?
3, 4, 6.
3, 4, and 6. Why don't I write 4 twice?
That's stupid.
Because yeah, well actually it's a pretty, you just don't have to. It's already there. The domain is the set of all input values. Theoretically, you say 4, 4, 4, 4. No, it's just 4. What about the range of this function, Nick? What's the range? The domain is the set of all input. Range is the set of all
Y's.
Yeah, so what are the y values?
1, 2, 5.
Yeah, done. Nice. Could we write it a little differently? Sure. Milo, can you tell me what the domain is of this function b on the left? What's the domain of that one going to be?
95, 98, 89, 88.
Done. So sometimes identifying the domain and range is really straightforward. It's literally taking a list, taking a set of things, and putting them in a list. What about, though, if I gave you the function itself? So let's say let's look at the one on the right here. How many points are on that oval right there? How many points are on that oval?
A lot.
How many is that? A lot. There's an infinite number of points there. So can you list all of the points that are on something if it's infinite?
You could say that's infinite, because isn't there like an enclosed area?
No, it's an enclosed area, but how many points are on the oval?
A lot.
How many? Infinite.
But I don't the
Yeah.
number.
Kids, wait. Ready? There's a point here.
But there's a certain number.
No,
It
there's
doesn't go on forever.
it goes on forever. There's an infinite number. This is an oval. How many points live on this? An infinite number.
There's a lot, but there's not like a forever.
There's a forever. No, there is forever.
Yeah, because you.
Because look, ready?
There's a thing.
Yeah, exactly. If I have a line segment, can you zoom in? Yeah. You see that segment right there? Think about it this way. Ready? Here's how I think about it. We talked about this a little bit. 1 and 2. How many numbers exist between the numbers 1 and 2? An infinite number, right? There's an infinite number. So how many points are on this oval? An infinite number, right? You could stretch it out if you want to, but you could always zoom in.
So you can say that about any 2 points, right?
Anything that's a segment, yes.
So like 2 points on line.
Between any 2 points, there's an infinite number of numbers. It's called a dense set. It's really cool. So can you possibly list all the things in the range?
No.
So instead of listing them, you have to describe them. Let's look at the domain first here. The domain is the x values. What's the biggest value x can be?
-4.
Biggest value x can be.
4.
X can be 4. What's the smallest value x can be?
0.
Nope. 4. This is the domain. What about the y values? What's the biggest y can be? What's the smallest? Yep, and this is the range. What I like to think about when I think about domain and range when I'm looking at a function, the shadows. If I'm looking straight down, what would the shadow of this thing be? -4 to 4. If I look at it sideways, what would the shadow be? -6 to 6. Is this a function? What do you think? Is this oval a function?
Yes.
Are there any x values that have more than one y value?
Oh,
Wait, no, it's a function.
You sure?
Yeah.
Okay, let's test this. At x equals 2, what do you see? I see a point there, and I see a point there. So at 2, it looks like that could be like 2, 5 or something, right? I don't know, I'm just estimating. 2, 5. And this could be 2, -5. It's the same x value. So you have the same x value, but how many y values?
2.
So is that a function? So this is a relation. So visually, how can you determine domain and range? You think about those shadows. Let's do this one right here. That's a line. It is a function. Anybody want to guess what the domain of this thing is? Anybody? What's the domain?
It's infinite.
So what's it when you say you can just call it all real numbers? And what's another way to say that? -infinity, infinity. And another way is this, and another way is ARN. It's all the same. What about the range? Are there any x values where this isn't defined? It goes on forever, right?
Yeah.
What's the shadow going to be?
Forever.
Forever. What's the sideways shadow going to be?
Forever.
Forever. So what's the range?
Forever.
Yeah, so you know, the range and it is forever. Aww. Are we in Twilight? I don't know. What's the domain here? Yeah, don't get me started on that. Not going to do that because I don't have the energy right now to dismantle that thing. What's the domain of this? How wide does it? Yeah, it covers everything, right? What would the vertical shadow be? It would be everything. So the domain here is all real numbers. Be careful here. What's the range? Someone raise their hand and then I'll call on you. You can tell me what's the range of this one, Aubrey. That's the lowest. That's the lowest one. -3 to what?
Infinity.
Yeah.
Why isn't that for the domain?
Because the domain is. You see these arrows? It keeps on getting wider, right? So how wide does it get? Keeps going, right?
Okay.
What about verticality? Oh, but it stops here. Can it ever go below -3?
Yes.
It can't. So it contains it. Goes up.
Understood.
Any vertical line here? No. So guess what? It is a function. What about this one? Are there any vertical lines that pass through it more than once? No. Do this. It's never going to pass through, so it is a function. So you might ask yourself, what about things that aren't functions? Well, sideways parabola right here. How many vertical lines can I draw that pass through more than one point? Quite a few. Oh, look at this one. And this one. So is this a function? No. It's just a relation. So that vertical line test says this. If every vertical line intersects the graph of a relation in no more than one point, the relation is a function. So if I graph something like this, whee, is that a function? No, because I can draw this line, and it's not a function, because I can draw one line that passes through more than one point. Okay, so let's wrap this up here for a second, talk about domain and range at the end. Here's a line. It looks like this. I have to put the axes on, but it looks something like that. What's the domain of that function, Summer? Domain is the, what's that called? Yeah, what's that called? Come on, someone help her, what's it called? What? No, the domain is the set of numbers, and she's saying it's infinite. We don't say the domain is infinite, we say it's all real numbers. It's all real numbers. What about the range of this thing?
Not always.
But for this one it is.
Yeah.
It's all real numbers, right? Because it goes infinitely, the domain because it goes infinitely left and right, the range because it goes infinitely up and down. But what about this one right here? This is a little crazier, right? Because what did I add into that? That's not a line, that's a radical, right? There are two mathematical operations that you are kind of disallowed from doing, right? One of them is dividing by 0. We don't like dividing by 0, right? What's the other one that we don't like to do? That has to do with this. We don't like to square root what? Negatives. We do not like to square root negatives. The square root of -2 is imaginary. We don't like imaginary numbers. We want real numbers. So in this case, 2x minus 1 must be what? Must be? We just said we don't like the square roots of negative numbers, so this has to be positive or equal to what?
0.
Yes. Is it okay if it's 0?
Sure.
What's the square root of 0?
0.
Yay! But it has to be 0 or positive. Can you solve this? What do I do first to this, Zoya? Add 1. Then what do I do, Nick?
Divide by
Yeah. And what did you just find?
slope.
Nope.
I'm so sorry.
Don't apologize. What did you just found something. I'll give you a hint. It begins with a D. It's the domain. You just found the domain right there. Because you found for this to be positive, x has to be greater than or equal to 1/2.
So you just get rid of the.
Not getting rid of it, you're saying for this to be okay, for this to be evaluatable, for you to be able to evaluate this has to be positive. You're not getting rid of it, you're saying for this to be a legal operation, this has to be true. For this to be true, that has to be true. So how about you try one? How about you try one? Not this one. How about you guys try, if I can move that down, try a different one. Y is equal to the square root of 2 minus x over 3. Tell me what the domain of that function is. What did you set up? What did you have to start working with? What was the first thing you wrote down? Zoya, yeah? Y equals? What's the first thing you started with?
2 minus x over 3 is
Greater than or equal to 0. Yeah. When you multiply both sides by 3, what do you get, Harry, on this one? When you multiply both sides by 3, what do you get?
You get 2 minus x.
Is greater than or equal to? Yeah. Keep in mind, when you multiply 0 by anything, what do you still have? 0. So, negative x is greater than or equal to? Or no. You're subtracting 2, so negative x is greater than negative 2, but we don't like the negative, so we have to multiply by negative. So it becomes x is what? Nope. Yes, 2 over here, but what goes in the middle? Flip it to what? Neither one of those things. You're close.
and equal to that.
Yeah, there it is. So x is less than or equal to 2. What did you just find for this function? You just found the domain. I will tell you, finding the range is very different. We're not going to find the range on that one. No, not on that kind of function. Okay, so last thing I want to talk about is this right here. Y squared equals x. If I asked you to graph that, I don't want you to graph it right now, but if I ask you to, if you don't know, if you don't have like some system, there's no slope to that, right? Because that's not a function. Sorry, that's not a line. If you don't have some sort of step or steps or system to follow, what can you always do? You can always plot what? A point. And then you could try plotting another point, and another point, and another point. And then what do you do with all those points? You connect them. So for example, let's say I made a table, do not pack up. Packing up early makes me unhappy. Please don't pack up. If you plotted a bunch of points, and it looked like this, it doesn't, but let's say it did look like that, do you have a pretty good idea of what this looks like? Yeah, it looks something like this, right? So you would need to make a table. So if you ever get something like this, you could plot points. So what I mean by that is you can make a table. And in this case, let's pick some y values. How about 1, 2, and 3? If y is 1, what's x?
1.
1. If y is 2, what's x? 4. If y is 3, what's x? 9. I'll pick negative 1, negative 2, and negative 3. If y is negative 1, what's x? 1. If y is negative 2, what's y? Sorry, if y is negative 2, what's x? Plug in negative 2 for y, what do you get? 4. Plug in negative 3 for y, what do you get? Sorry, for y, what do you get? 9. Is this a function? No. 1 goes to 1, 1 also goes to negative 1. If you graph this thing, this is what it looks like. Whee! This is called a sideways parabola. That does not pass which test? The vertical line test. This is not a function.
So did you just do the opposite?
I did the opposite because it was easier to evaluate. Because if I picked x values, it's kind of hard to find y.
Yeah.
Like for example, if I pick 7, what's y? The square root of 7, right? I just picked it the other way. You can pick any values you want. I just picked ones that were easy to work with this equation. Yes, Nikki.
So when finding the domain,
Yeah, what would be the domain of this? What's the horizontal shadow? From 0 going which way?
to the right.
To the right. There it is. Yeah, what's the range on this one? Can anybody tell me the range?
Yeah.
How far up does it go?
Infinitely.
How far down does it go? So what's the range? What's that called? All real numbers. Pretty cool, huh?
But doesn't the range stop at the...
Nah, it doesn't stop. Keeps going. Keeps going this way.
But this isn't x going negative and positive, and you're only going to the positive point?
X is only positive. X is only positive. So just look at this picture right here. How wide does it get this way? How far up does it go? How far down does it go? How far down does this go? You see? So it goes down and up. Okay. So we're going to end right there. Do not pack up.